Example problem 8.6. Two identical springs of spring constant K are attached to a block of mass M and two fixed supports as shown in figure. So here a block of mass M is attached to identical spring of spring constant K. So show that when the mass is displaced from its equilibrium position on either side, it executes a simple harmonic motion. So if the block is displaced from its mean position, so we have to show that the bob executes a simple harmonic motion, and also find the period of oscillation. So we have to find time period. Here it is mean position. If the block is displaced by a small distance x to the right side of equilibrium position. Here left side of the spring is elongated and right side of the spring is compressed. The forces acting on the mass are, here it is F1, this one is F2 force. So here F1 is equal to how much? That is equal minus Kx. So this force exerted by the spring on left side trying to pull the mass towards the mean position. So here F2 is equal, here also it is minus Kx. So this force exerted by the spring on the right side trying to push the mass towards the mean position. So the net force C is F is equal F1 plus F2. So that is called minus Kx minus Kx. Here F is equal minus 2Kx. Here force on the mass is directly proportional to displacement in magnitude and it is in opposite direction. So and the force is always towards the mean position. So the mass is execute simple harmonic motion. So the mass is execute simple harmonic motion. So here what is the time period? Time period T is equal to 2 pi under root of m by k. Here k is equal to how much? It is 2k. So here I am writing 2k. So here time period T is equal to 2 pi under root of m by 2k. See example problem 8.7. A block whose mass is 1 kg is fastened to a spring. The spring has a spring constant of 50 Newton per meter. The block is pulled to a distance x is equal to 10 centimeter from its equilibrium position at x is equal to 0 on a frictionless surface from rest at t is equal to 0. Calculate the kinetic energy, potential energy and total energy of the block when it is 5 centimeter away from the mean position. So here mass of the block is given, so that is 1 kg, and spring constant is given, that is 50 Newton per meter, and so here this distance is given, that is x is equal to 10 centimeter, so that is maximum amplitude is given, and so we have to calculate kinetic energy, potential energy and total energy when the block is at 5 centimeter away from the mean position. Mass of the block is given, so that is m is equal 1 kg, and the spring constant is given, so that is called 50 Newton per meter, and maximum displacement is given, so that is called A. Here it is 10 centimeter, so that is called 10 into, here 1 centimeter is called 10 to the power minus 2 meter, so that is called 0.1 meter. So here in a spring block system, here it is mean position, x is equal to 0. Here the block is displaced 10 centimeter from its mean position. So here x is equal to 10 centimeter. The block is executing oscillations. Here we have to find if the block is at x is equal to 5 centimeter. We have to find kinetic energy, potential energy and total energy. See here angular frequency omega is equal to under root of k by m. So here from this omega is equal to under root of, here k is how much? It is 50 by m is equal to 1 kg. So that is called root 50. So here root 50, it is near to 49. So 7 7 the 49. So angular frequency omega is equal to how much? It is 7.07 radians per second. So the displacement of block at any time t is, how we can write? So at any time t, the displacement of block is x of t. How we can write? A cos omega t. So here x of t is equal to, how we can write? Here a is 0.1 cos omega is equal to how much? It is 7.07 t. So here we have to find kinetic energy, potential energy and total energy at x is equal to 5 centimeter. So if x is equal to 5 centimeter, so that is called 0.05 meter. So here 0.05, that is called 0.1 into cos 7.07 into t. From this cos 7.07 t is equal to, how we can write? That is 0.05 by 0.1. So that is equal, if we remove point, so here it is 2 digits, here it is 1 digit, so we can write 5 by 10. So that is equal cos 7.07 t is equal to how much? That is called 0.5. So from this, what about sin 7.07 t? So that is called square root of 1 minus cos square theta. So here cos square theta is called 0.5 whole square. So that is equal, so here 5 by 10 is equal to how much? It is 1 by 2. So here it is how much? 1 minus 0.5 is equal to 1 by 2. 1 by 2 whole square, that is 1 by 4. So that is equal, here 4 1 the 4, 4 minus 1 3, square root of 3 by 4. So sin 7.07 t is equal to how much? It is square root of 3 by 4. Cos 7.07 t is equal to how much? It is 0.5 or 1 by 2. Here the velocity of the block at x is equal to 5 centimeter is at x is equal to 5 centimeters, so that is 0.05 meter. So we have a formula, v is equal a omega sin omega t plus pi, that is omega t. So here a is given, so that is how much? 0.1 into omega is how much it is 0.70 into sin omega t value, so that is sin 7.070 value, so that is root 3 by 4. So from this we can get how much it is 0.61 meter per second. So velocity of the block at x is equal to 0.05 meter is how much it is 0.61 meter per second. So now we have to find kinetic energy of the block. So kinetic energy is how much? Here it is half mv square. So half mass of the block is 1 and velocity is 0.61 into 0.61. So here 2 ones are, here it is 2 ones are, 2 3s are, 2 5s are 10. So here it is 0.305 into 0.61. So here 6 3s are 18. So nearly it is how much it is? So that is 0.19 joules. So here kinetic energy is how much? 0.19 joules. The potential energy of the block is, so here potential energy is equal to half k x square. So here half k is given how much it is 50. So x is known value, that is at 0.05 centimeters. So that is 0.05 into 0.05. So here 5 ones are, 5 twos are. So here 5 5s are 25, 25 25s are 625. Here 625. So here it is 2 digits. Here it is also 2 digits. So 1 2 3. Here we have to take point. So potential energy is 0.0625 joules. So total energy. So the total energy is equal to kinetic energy plus potential energy. So kinetic energy is how much? So that is 0.19 joule plus potential energy is 0.0625 joule. So your total energy is equal to how much? So that is 0.25 joules.